Okay, so let's continue our discussion by the next question, which is from 2019, 2020, which is our past year's question. Alright, so for the first one, which is A, figure 9.5 shows the potential energy of 0.5 kilogram object that undergoes a simple harmonic motion. Determine the velocity when time given is 2 seconds and the kinetic energy of the object when displacement is 1.5 meters. Okay, now by giving you a graph which is U against X. So what is U? U representing the potential energy and X representing the displacement. So according to this graph, we may conclude that the maximum displacement now is 3 here. So this is our amplitude. Okay, so the amplitude given already. Alright, so this is our equilibrium and this is another amplitude. So remember, for any simple harmonic motion, the object is moving back and forth again and again, from amplitude to another amplitude through the equilibrium. Alright, so according to this situation, what do we have? Okay, the first info given is the mass of the object which is moving now. Okay, so now they ask you to find the velocity at 2 seconds, also the kinetic energy when the displacement is 1.5 meters. See, so what info do we have actually? The first one is mass. Okay, this is the mass, and don't forget this is the amplitude. So at the amplitude, the potential energy is maximum, so this is our Umax, maximum potential energy, because the potential energy is maximum at the amplitude. Why? Because the amplitude, at the amplitude, the kinetic energy equals to 0. Why? Because V equals to 0. At the amplitude, by reaching the amplitude, the object needs to stop for a while to change its directions to be backward, isn't it? So it needs to stop for a while. That is why V, or velocity, equals to 0. When velocity equals to 0, the kinetic energy, which is half mv squared, also equals to 0, giving you the maximum potential energy. Okay, so at the amplitude, U is maximum, which is 13.5 joule. So by knowing the maximum potential energy, by knowing the mass, then they ask you to find the velocity. So how to find the velocity? Alright, so normally for the velocity, we have two different equations that can be used in calculating the velocity. The first one, and the first question, which is A, number 1. To calculate the velocity, velocity equals to dx over dt. So by differentiating x with respect to t, giving you velocity. So we need to know the equation of x lah, or displacement in terms of t. Or by using the equation of velocity, which is equals to omega square root of a squared minus x squared. So we have two choices here. By using the displacement equation, then we just differentiate the equations, or by using the velocity equation directly here. Okay, I want to show you how to find the answers using two different methods here. Okay, all right, so for this, generally we know that the equation of, okay, it seems like there is no info given when t equals to 0, isn't it? So we doesn't know, it just start from the amplitude or equilibrium. So to have something like this, so normally we just assume that the object starts from the origin. So basically the equation is x equals to a sine omega t. Okay, basically, because there is no info given when t equals to 0, where is the position of the object. So basically, x is the displacement equals to amplitude sine omega t. So to use this equation, okay, to find the velocity, we need to differentiate the equation. Okay, x with respect to t, isn't it? So amplitude given already, which is 3, and then, okay, time, okay, first we need to differentiate the equations, but omega is not given, isn't it? Then we need to find the omega first. Okay, before we just differentiate the equation, we need to complete the equation. A given already, but omega is not given. Then we need to calculate omega. So how to calculate omega? By using the maximum potential energy given. Okay, from the equation of potential energy. Potential energy equals to half K A squared, isn't it? Where K equals to M omega squared. So this is K actually. Alright, so U is given already. So U is maximum when the displacement also maximum, which is equals to amplitude, isn't it? So at the amplitude, U given already as 13.5 joule. Substitute the values here. 13.5 joule equals to half. Okay, the mass is given already, which is 0.5. Okay, times by omega squared, and the amplitude given is 3 meters. Substitute the value of amplitude here. Alright, so based on this, you will get omega. So omega equals to, please calculate first. I think you will get the same answer as 2.45 radian per second. Okay, by getting omega, and then we just substitute this omega into this equation, giving you x equals to 3 sine 2.45 t. So this is the equation of displacement in terms of t. So to find v, v equals to dx over dt. We need to differentiate the equations where, according to the general equation, v dx over dt giving you a omega cos omega t, isn't it? How do you get that? It's quite simple. Okay, please refer to the equation here. Okay, what do we have now? First, 3 just a constant. Okay, and then we need to differentiate the function of sine with respect to t. You will get cos. Okay, so giving you cos 2.45t. For the first step, we need to differentiate the cosinus function here. Sine with respect to t, giving you cos 2.45t. And for the second step is we need to differentiate the values inside the bracket with respect to t, which is 2.45t with respect to t, giving you 2.45. Okay, so we just calculate all the constant here. 3 and 2.5 just a constant. We just calculate together here, giving you 3 times 2.45, giving you, okay, leave it first. Okay, cos 2.45t. So this is the equation of v. So by getting the equation of v here, and then the question asks you to find the velocity at times equals to 2 seconds, isn't it? So we just substitute the value of t into this equation, so that you will get 3 times 2.45 and then multiplied by cos 2.45 multiplied by the time given, which is 2 seconds. Okay, but remember, in using this equation for chapter 9 and chapter 10, remember the mode of the calculator should be in radian mode. And please check your calculator. Okay, make sure that the mode of the calculator should be in radian. Okay, so just calculate the values of velocity here. I think you will get the answers to be 1.37 meter per second. Okay, so by using the first method here, which is v equal to dx over dt, you will get this answer. Okay, now I want to show you how to find the answer using the second method here. I think it's quite simple using the second method here. Alright, or by using the equation of v equals to omega square root of a squared minus x squared. Okay, in using this second method, okay, let me separate the answers first because we are talking about two different methods. Let me separate the first method just above there. This is the second method. Okay, so in using this, we need to find x first. What is the value of x at 2 seconds? Okay, so based on that, okay, we just find x first. X equals to, the question before is a sine 2.45 t. So the amplitude given is 3, and then the question is sine 2.45 t. Okay, so now the time given is 2 seconds. We just calculate x. So x equals to 3 sine 2.45 times t given is 2 seconds. Okay, what is x getting now? Alright, so based on my calculation, seems like x getting now is equals to 2.95 meters. Okay, by getting this x, we just substitute into this equation where omega calculated before. Still the same, we are using this equation in calculating omega. By getting omega, substitute into this equation. So omega is 2.45 multiplied by a squared. A squared is 3 squared minus x calculated just now, which is 2.95. Make it squared again. Okay, giving you the answers of velocity here, which is plus minus 1.37 meter per second. So this is the answer. Still the same actually. Okay, but what is the difference by using these two different methods? Okay, by using the equation of v in term of t, the final answers getting out is really in positive or negative. So we may get the direction of v, which is directed to the left or to the right. But by using this equation, we are talking about the square root equation here, so that the final answers getting out should be in plus and minus. So based on this, we may get the magnitude, but we doesn't know the direction. Is it to the left or to the right? That is why normally by asking you to find the direction, the best way is we just use this equation. V equal to dx over dt, because by using this equation, the final answers getting out just in positive or negative. So directly you may get the directions too, compared to this one. Okay, alright, so this is the way how do you answer the first question, which is A1 here. We need to calculate the velocity at 2 seconds. So we may use this method or this method. Okay, still the same, but to answer the question, we need to find the omega first using the potential energy equation. Alright, okay, and then for the second part A2, kinetic energy of the object when displacement x equals to 1.5. Alright, so for this, the keyword is kinetic energy. Okay, and the displacement given is 1.5. So how to find the answers? Okay, we just use the equation directly. Okay, this is question A2. Alright, so the equation of kinetic energy. Kinetic energy symbol is K. K equals to half K A squared minus x squared, or K still, this is small k. Okay, I want to explain you. We are talking about two different K. Capital K representing the kinetic energy, and this is our small k, which is our constant, where the constant is equals to m omega squared. Alright, so based on this, we just substitute all the values. The mass is given already. Omega calculated before here. This is omega. Substitute into this equation. Amplitude given already, which is 3. And x, x given is 1.5 meters. Substitute into the equation so that you will get the answer. So the mass is 0.5 kilogram. Omega getting before is 2.45. Okay, we got square here, don't forget that. Okay, multiplied by A is 3 squared minus the displacement is 1.5 squared. Okay, giving you the answers to be 10.13 joule. Okay, so this is the way. Okay, let me separate the answers again to avoid any confusion here. Okay, alright, so this is the way how do we answer the first part, which is number 9A, 1 and 2. So we just use the equation directly, but remember again, don't forget to check the mode of the calculator. Make sure it's just in radian mode. Okay, next, number 9B. An oscillating pendulum has length 0.3 meters and 240 gram bob. If the total energy is 0.06 joule, calculate the amplitude of the oscillation. Okay, as usual, we need to identify what do we have in the question, what info given here. Okay, the first one is length. The second one is mass. But remember, the mass given is just in grams, so we need to convert it to be in kilogram, okay, for the calculation. And then this is the total energy. Alright, then they ask you to find the amplitude. Okay, how is it? Alright, so according to this equation, okay, let me change the color lah to separate answers. So this is number 9B. Okay, so what do we have? Length equals to 0.3 meters and the mass given is 240 gram or 0.240 kilogram. Okay, the total energy E total equals to 0.06 joule. So they ask you to find the amplitude. Alright, so basically what do we have now? L, mass, also the total energy. So they ask you to find the amplitude. Alright, again, the main equation of E total. E total still equals to U max still equal to K max. Okay, because when K is maximum, U is 0. Or when U is maximum, K is 0. So they are equal to E total. Okay, so E total here still equals to U max, which is half K A squared. Again, K is M omega squared and multiplied by A squared. So that one is E total. Okay, so based on that, how to find the amplitude? Okay, to find the amplitude, okay, E total given already, mass given already, but omega is not given here, isn't it? So that we need to find the omega. So how do you find the omega? Please check what info do we have. How do you find omega? To find the omega, we need to find the period first. Okay, why? Because omega, if period equals to 2 pi over omega. So that omega equals to 2 pi over period. So we need to find period first. So for any pendulum system, period equals to 2 pi square root of L over G. Alright. Okay, so G just a constant, which is 9.81 meter per second squared. Why? Because we just conduct the experiment on the Earth's surface. L given already, which is 0.3. That one is L. Okay, and then we just calculate period. Okay, so equals to 2 pi square root of L. L given is 0.3 divided by G, which is 9.81. So that you will get the period. The period getting now is equals to 1.1 second. By getting the period, and then we just substitute into this equation, giving you omega. So 2 pi over period, which is 1.1 second, giving you omega, which is equals to 5.71 radian per second. This is omega. So by getting the omega, and then we just substitute this omega into this equation, then we may calculate the amplitude. Okay, E total given already, substitute here. Mass also given. Okay, omega calculated just now, then we may calculate amplitude. Okay, so substitute all the values. So E total is 0.06 equals to half. The mass given is 0.240 kilogram. Omega getting here is 5.71, make it squared, and A squared. So based on our calculation just now, A getting now should be equals to 0.12 meters. So this is the way. Okay. Alright. So again, to find the amplitude, we need to find the omega because omega is not given. So to find the omega, we need to find the period because the period also is not given here. Then we just calculate period first. By calculating period, substitute into this equation, you will get omega. By getting omega, substitute into this equation, then we may calculate the amplitude. So this is the way how do we answer the question. Okay, so let's continue by the second question. Okay, so this is past year's question 2, which is from 2020-2021 session. Alright, so for this question, what do we have now? There is a graph given which is y against t. Okay, normally the question, graph given is x against t. So sometimes it can be y against t. Okay, what is the difference? The oscillation now. By having y against t graph, seems like the oscillation just in vertical. So the object just oscillating upwards and downwards. By giving you x against t, means that the oscillation just on horizontal, or the object is moving to the left and to the right for the oscillation. That is the difference. Okay, still the same for the concept. Okay, so based on this graph, figure 9.6 show the displacement against time graph of a body performing simple harmonic motion. How do you know? Based on the sinusoidal pattern graph here. Starting from equilibrium, reaching the amplitude, turn back to the equilibrium, reaching another amplitude, turn back to equilibrium. This thing happen again and again. That one is under simple harmonic motion. So based on this, what do we have? This is the amplitude, because 2.0 is the maximum displacement. That one is the amplitude. And for one complete oscillation, the time is given here. So this is period. So what do we have? This is the amplitude, and this is the period. You need to know that. Okay, because this is one complete oscillation. All right. Okay, so based on that, they ask you to find the amplitude. Okay, angular frequency, which is omega, also the maximum speed. And then they ask you to deduce the expression of the graph, which is y against t. So they ask you to deduce the expression of displacement in term of time. Okay, and then sketch velocity against time graph. Okay, so how to answer that question? All right, first, and determine the amplitude. Okay, so amplitude given already. So from here we know that amplitude, okay, that one is A1. Amplitude equals to 2.0 meters. Settled already. Second question, angular frequency. Angular frequency, omega equals to 2 pi over period, isn't it? Period given already, which is 5.0. Okay, so 2 pi divided by 5.0 giving you the omega, which is equals to 1.26 radian per second. That is omega. Okay, and then the third one, they ask you to find the maximum speed. The maximum speed. Okay, so basically this is the equation. Sorry, this is the graph, where the graph is purely sine, isn't it? So basically the equation of x equals to a sine omega t. Okay, to find V, we need to differentiate the equation, isn't it? So V equals to dx over dt, giving you a sine omega t, you will get cos omega t. And we just differentiate the cosinus function, which is sine with respect to t, giving you cos omega t. And then we just differentiate the values inside the bracket, which is omega t with respect to t, giving you omega. So that you will get V equals to A and omega, just a constant. We just collect together omega cos omega t. This is V. Alright. So remember, this is our cosinus function, which is cos omega t. The values of any cosinus function is between 0 until 1. So by talking about maximum V, cos omega t also maximum, which is equals to 1. Because this is minimum and maximum values of the cosinus function here, isn't it? So to find V max, cos omega t also maximum, which is equals to 1. So that from there, when cos omega t equals to 1, V is maximum. So that V max equals to A omega. No more cos omega t, because cos omega t equals to 1. So substitute the value of A given here, which is 2.0, multiplied by omega calculated before, which is 1.26. This is omega calculated before, isn't it? Substitute into this equation, giving you V max. So that V max getting now equals to 2.51 meter per second. Okay, settle the first part, which is A. They ask you to find the amplitude, they ask you to find the angular frequency, they ask you to find the maximum speed. Okay, settled already. Now we just turn to the second part. They ask you to deduce the expression for the motion. Okay, so deduce the expression for the motion based on the graph, which is y against t. So they ask you to take out the equation of displacement lah. Okay, so for the second part, as we know, y equals to a sine omega t. Oh, okay, sorry, the oscillation just on y component, isn't it? So I need to change the symbol here to be y. It's not x, sorry. Okay, this one is y actually, because the oscillation just on y component. So y equal to a sine omega t and dy over dt. Okay, sorry. So the oscillation just on y component. So the general equation of displacement is y equals to a sine omega t. So that for the first differentiation, which is dy over dt, giving you velocity. Okay, something wrong with the symbol only. Okay, so again, to deduce the expression, we just substitute all the values given before, okay, or calculated just now. So the amplitude is 2.0 sine, and omega calculated before is 1.26 t. So this is the general equation. Okay, but more for safety, I like to explain the unit lah, where y in meters and t in second. The unit of y and time. Alright, settle for the second part. And now for the third part, which is sketch velocity against time graph. Okay, how is it? How to sketch the graph? Okay, basically, this is the general equation of displacement. Okay, and for the first differentiation, you will get the equation of velocity, isn't it? Alright, where the equation of velocity getting now just in cos. So we just sketch a cos graph to be like this lah. Okay, so how to sketch the graph? Okay, let me change the color first. I take the green one for the axis. Okay, so this is the y-axis. Oh, sorry, I need to use my ruler. Okay, this is the y-axis, and this is the x-axis. Okay, so now the graph is purely cos, because the equation getting now is cos. Cos here. Okay, so for any cos graph, the graph should be like this, starting by the amplitude, isn't it? How to sketch the graph? Okay, cos, this is cos graph. Okay. Hey, wait. I haven't deleted the ruler. Sorry. Again, this is our cos graph. Maybe just sketch the graph to be like this. Okay, so don't forget to label the graph. This is V, which is in meter per second, and this is time, which is in second. And for one complete oscillation, that one is period lah. Okay. Alright, so the period given is 5, isn't it? So don't forget to label. Label the period, which is 5. And this is the amplitude, which is V max. V max before getting now is 2.51, isn't it? So this is V max. Label it here, which is 2.51 meter per second. And this is the negative amplitude. Okay, so don't forget, by asking you to sketch any graph, don't forget for the label and unit. Also the values on the y-axis, also on the x-axis, at least for the period, also V max. So the marks given for these 3 items lah, label and unit, and then the label on x component, also on y component. Don't forget that, and also the shape. Okay. Alright, so I think enough for these 2 questions. Maybe you may find another question, and take it as your own exercises. Try to answer the question to check your understanding. Okay, understanding here for the concept lah.